Okay, in doing this problem here, it's highly important that we visualize what's going on. And so I'm going to make a vector equation L. Here is L. And I know that point P is on L. And here's O. Here's the origin. And point P is on L in such a way so that OP is perpendicular, because that will ensure that it's closest to the origin. Okay, and so P can really be any point on this current, but I want this specific point here. And so that's going to help me. I have to recognize that this vector OP is perpendicular to the line. But I know that the line can be explained by this vector. So here is the direction vector of the line. And so what I'm going to do is I'm going to make a dot product between OP and the direction vector of the line 4, 5, minus 1, and I'm going to make that equal to 0. And when that's true, if this vector OP and the line are perpendicular, the dot product will be 0. So to find vector OP, P is any point on this line, O is the origin, so I'm going to go P is going to be the x values, subtract the 0, 0, 0, 0, 0, 0. And so point P can actually be -1 plus 4t, 3 plus 5t, and 8 minus t. That is point P. And subtracting it from 0, it's also OP is this vector here. So it's -1 plus 4t, 3 plus 5t, 8 minus t. This dot 4, 5 minus 1 has to be 0. And I'm going to solve for t, and that will put it exactly there. And so when I do the dot product, I get -4 plus 16t plus 15 plus 25t minus 8 plus t equal to 0. And so this is, I have, that's 30, 41, 42t. I hope I'm doing my computations correct. 15 minus 8 is 7 minus 4 minus 3 equals 0. And so t is equal to 3 over 42. Ugh. So let me just check here. It's plus 3. So the minus, so it'll be minus 1 over over 14. I take, this is my point P, or my vector OP, so my point P. If I take that in, I'm going to go -1 plus 4 times -1 over 14. 3 plus 5 times -1 over 14. And 8 minus -1 over 14. If I do this calculation, that will give me point P. The key to it is recognizing that you have to create this vector OP, and it has to be perpendicular to the direction vector.